Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. So let's have Vitamath 76, a problem in calculus, applications of slope of tangents to curves or derivative as slope. Find points P and Q on the parabola y equals 1 minus x squared. This is a parabola that is open downward with vertex on the y-axis and is symmetric with respect to that y-axis. So when x is 1, y is 0, plus minus 1, y is 0. And when x is 0, y is 1. So let's look at this in the figures on. So that triangle ABC formed by the x-axis and the tangent lines at P and Q is an equilateral triangle. Here is the given figure. We have points P and Q as points of tangency. This is the green curve is the parabola with equation y equals 1 minus x squared. And that is why when x is 1 plus minus 1, y is 0, and it is just to the curve is just to the right of B and just to the left of C, very close to P and Q. And when x is 0, y is 1 here. So this is the parabola y equals 1 minus x squared. So the triangle ABC formed by the x-axis and the tangent lines at P and Q is an equilateral triangle. So A only triangle ABC bounded by points ABC is an equilateral triangle. So from y equals 1 minus x squared, we know that the derivative of y with respect to x corresponds to the slope of the tangent to the curve. Slope of the tangent to the parabola. And the points of tangency are P and Q. So since BA is one side of this equilateral triangle, and by symmetry, the angle here, the tangent of the angle here, the tangent that the angle BA makes with the positive x-axis, so that is counterclockwise, is 60 degrees. The tangent of 60 degrees is the slope of BA. So because that's 60 degrees, slope of BA is tangent of 60 degrees, which is positive square root of 3, and that is dy dx here. While the slope of CA, because this is also 60 degrees, the angle that CA makes with the positive x-axis is 180 degrees minus 60 degrees. So this angle here, the measure of this angle is 120 degrees, also counterclockwise, which is in standard form. Slope of CA on therefore is equal to tangent of 120 degrees, and it is equal to negative square root of 3. So we can now solve for the x-coordinate of the point of tangency P by equating here m of BA, which is equal to square root of 3. So square root of 3 equals negative 2 times xp. So xp is negative square root of 3 over 2. Likewise, we substitute here negative square root of 3 to solve for xq. So negative square root of 3 equals negative 2 times xq. So that means x sub q is equal to positive square root of 3 over 2. Then we can now compute yp and yq. They are expectedly equal because of symmetry. They lie on the same horizontal line. And we can find that by substituting the values of x into this equation. So yp equals 1 minus xp squared, while yq is also 1 minus xq squared. Since this is squared, plus minus negative square root plus minus square root of 3 over 2, quantity square is the same. So yp equals yq equals 1 minus quantity plus minus square root of 3 over 2 squared. And this is 3/4, and 1 minus 3/4 is 1/4. So yp equals yq equals 1/4. We, we have now found p and q. So point P would be at negative square root of 3 over 2 comma 1/4, while Q is at positive square root of 3 over 2 comma 1/4. So that's it for this video. I hope that you understand the explanations and the solutions.